Alrighty. Hello, everyone. Welcome to Cassandra Lunch number 91, almost at that big 100. Today's topic is going to be on collections in Cassandra, and Obi is going to discuss collection types in Cassandra and how the frozen modifier changes the way Cassandra interacts with them. Obi is an engineer here at Anant. The co-organizers for this event are Rahul and myself. We are looking for guest speakers as well as sponsors. If you're interested in giving a talk for Cassandra Lunch or even our sister lunch, Data Engineers Lunch, feel free to reach out to me. My email is listed below, and the same applies for sponsorships as well. We are a part of Data Community DC. Data Community DC believes in having an inclusive environment, so no matter your race, gender, sexual orientation, everyone is welcome, and we expect the respect to be given to all. Data Community DC is built up of a bunch of different organizations. Our sister lunch, Data Engineers Lunch, falls under Data Wranglers DC. So if you're interested in all the various events that Data Community DC fall under the umbrella, you can check out datacommunitydc.org as well as the various other sites per organization. So what do we cover here at Cassandra Lunch? We cover everything that is, talks to, or plays well with Cassandra. So whether that be open source Cassandra, managed or enterprise Cassandra, or compliant Cassandra, DataStax, Scala, Yugabyte, Keyspaces, Cosmos DB, as well as the surrounding ecosystem. So Spark, Kafka, Airflow, Kubernetes, etc. So everything that is, talks, or plays well with Cassandra, we cover here at Cassandra Lunch. So this is an opportunity. If anyone's new, feel free to drop a hello in the Zoom chat or the YouTube chat if you're watching live on YouTube right now. Group rules, if you have a question, ask it. This is meant to be a community, so please do share what you know with us or what would you like to get answered. But obviously, please be polite and courteous to the speaker. The speaker will announce their preferences for questions, whether that be in the chat or if they prefer you to speak up. But again, this is a community, so please do share what you know with us. Here at Anant, we design, build, and manage global real-time data analytics platforms surrounding Cassandra, Spark, and Kafka. So Cassandra is our bread and butter. DataStax is a partner and a sponsor. CW University also helps provide in-venue space when we have in-person events. We also have some organizational and institutional sponsors. If anyone has any jobs, meetups, hackathons, if they're looking for a job or has a job to offer, feel free to drop some links in the Zoom chat as well as the YouTube chat, and we'll get them transferred to Zoom and to YouTube so everyone has visibility. DataStax Astra has a build-a-thon going on, 3 months of challenges, 1 challenge per month. They've already started for the first round, so it might be a little late to get in, but you can go ahead and check it out. But for each month, they have a round of challenge. And with each round of challenges, there's the prize per monthly challenge, but then there's also the grand finale demo day prizes. And the grand finale, the top 3 winners for each round qualify to present their projects on demo day, which will be held at the end of the 3 months. So there's prizes that can be won within each month, but then if you end up being the winner for each round, you'll be able to win additional prizes for the demo day. So if you have any friends, coworkers that you're interested in partnering up with, feel free to check it out. I'll drop the link to the hackathon below. Anant is hiring full-time or part-time positions, whether that be a data platform operator, engineer, architect. If you're interested, you can find out more at careers.anant.us. Cassandra Lunch is now happening on Thursdays, same time, same place. We are looking at having a more variable time slot, so that way we can cater to a more worldwide live audience. But again, all these videos are streamed directly to YouTube, youtube.com/AnantCorp. So if you end up missing a live event, be sure to subscribe and turn on the notification bells so you can see when we're going live, as well as catch up with any pre-record or live streamed events directly to YouTube. Some upcoming events, our sister lunches happen on Monday at 12 p.m. Eastern. Again, we are looking at a more variable time slot. And Cassandra Lunches again happen on Thursdays at 12 Eastern currently. All these Cassandra Lunch videos are available on our YouTube channel, same as Data Engineers Lunches at youtube.com/AnantCorp. And you can find all the Cassandra Lunches starting from Cassandra Lunch number 10, because that's when we started recording. So from 10 to all the way till today, 91. You'll be able to find them on our YouTube channel. You can also just Google search it, and you'll be able to find it there as well. Cassandra.Link should be your #1 resource for all things Cassandra. If you have any questions or want to learn something about Cassandra or something in the ecosystem, go ahead and check out Cassandra.Link. Cassandra.Link is hand curated or is powered by hand curated articles and resources by the team here at Anant. So if you're interested in anything related to Cassandra, or if anything in the context of Cassandra in the ecosystem, such as Spark and Kafka, you can find tons of resources on those at Cassandra.Link. And with that, we'll go ahead and pass it over to our speaker today, Obi.
All right, as you've heard, I'm Obi Anant. I've been an engineer at Anant here for, I think, around 3 years. Generally, I prefer to take questions in the chat, but if we are between sections, such as in between the slide deck and the demo, or in between the demo and closing out, those are good times where you can unmute and ask questions if you prefer to ask that way. The topic today is Cassandra collections. We're going to be talking about the collection types in Cassandra and how they interact with the frozen modifier. We've discussed types a little bit in various Cassandra lunches here and there, but all the data that you store in Cassandra is typed, whether that be in text or something like blob, or as we'll see today, collections. So starting at the beginning, the collection type, collections generally, they group and they store multiple elements of data within a single column in Cassandra. So they act sort of like other data structures that you might see in other languages, which makes sense because Cassandra is built on top of Java. So something like Java types would make sense to see here. In Cassandra, there are 3 types of collections that you can use, as well as user-defined types, which we're not really going to talk about today, but they have a lot of the same features. The 3 are set, list, and map, and we'll go over their individual features and how they differ from each other in a little bit. When you're using collections in Cassandra, there are hard limits on the number of items you can store, the size of items you can store, and things like that for the individual collections. If you're using a list or a map, your elements can be up to 2 gigabytes. And your set, if you're using a set, items can only be 64 KB. And the max number of keys in a map is also, well, it's the same number, 64 KB and 65535 are the same because it's 1024 megs to a gig. When querying collections in Cassandra, Cassandra can only return the first 2 billion items, so never put more than that in the collection. It's a hard limit. There are also soft limits as to how you should use collections, which is that you never want to be storing data with potential for unbounded growth. So something like events, anything with timestamps probably shouldn't be stored directly in collections because essentially that can grow out of control. You'll be running up potentially against the hard limits, but more likely up against the soft limits and causing yourself performance deficits. And the main soft limit to be wary of is that when you're querying a collection in Cassandra, it has to read the entire collection. So even if you ask for a slice, Cassandra will be reading the entire collection in order to give you back what you want. Therefore, if you want to avoid performance impacts, you want to keep your collection small. So well below the 65,000 items that you could potentially store in a map. All right, so starting off with the set. A set is a group of unique elements. It's sort of analogous to a mathematical set in that the elements are unique. If you put in a duplicate item, it will be treated as the same thing. And while sets mathematically and theoretically in Cassandra are unordered, when you query, Cassandra will return your data to you in sorted order. So if you're storing ints in a set, it will give them back to you in numerical order. If you're storing text, it will give them back to you in alphabetical order. The creation syntax for a set, you define your column name, call set, and then there's the triangle brackets, and there you define what type goes inside. One thing is that you cannot use another collection inside without some specific details that we'll get into later. And when you're interacting with a set, so when you're inserting, when you're updating, etc., your items are comma separated and they're contained within curly brackets. And then this is something that we will actually look at during the demo. But when you look inside the SS table, elements in a set have a path and a value. And when you're using a set, the data is stored in the path variable and the value variable is left blank. A list is instead a group of elements that are in a specific order. You can put duplicate values in a list because they'll have different indices. So every list element is associated with a specific index and they're returned in index order when you query them. They can also be retrieved individually using their index. The creation syntax, just like set, except you replace with list. The interaction syntax they're still comma separated, but this time they're contained in square brackets. And then for their path and value variables inside the SS table, the actual value, like your data, is stored in the value variable. And then an index is actually a unique UUID, which is related to the actual indices in your list order, are stored in the path variable. And then lastly, maps. The elements of a map are key value pairs. So they're most analogous to Python dictionaries or JSON objects, if you're familiar with either of those. But basically, each element is a key value pair. Again, neither of these can contain other sets without using these modifiers that we're going to talk about a little bit later. So the syntax, you create both of your types inside the triangle braces to the right of the map. And for your interaction syntax, again, it's separated by curly braces. And then inside each element, the key and the value are separated by a colon. And then inside the SS table, I guess this one doesn't have an entry for that. But inside the SS table, the key goes in the path variable, and the value goes in the value variable. So you get to define both of them. And then importantly, each element in a map acts like a Cassandra column. So you can query, modify, replace, or delete elements within your map rather than having to affect the whole map at once. All right. So the frozen modifier. Frozen is something that you can add to any collection. What it does is it causes collection data for the rows within the table where you define a frozen collection column. Any data there is stored as a blob. So a blob is also a standard Cassandra type. It's just serialized binary data. Basically, what frozen does is it takes your collection, which is separated out into pieces, into individual elements, and it stores that all as a single value. What that means is that they become immutable. So without frozen, you could theoretically update a particular field within a collection. So you can add to a set a single element, or you can modify the value of a particular element in a list, or you can change the value of a particular key within a map. If you're using frozen collections, you cannot do any of that. Instead, what you need to do in order to change the value of something stored in a frozen collection is give that entire column a new value. So you'd have to set the value to a new list or a new set or a new map. The entire collection has to be overwritten. If you use frozen, you can nest collections within other collections. Again, the frozen collections will still be immutable, but they act as a single value within the set. So if you want to store a list within a set or any other combination, especially using lists or sets inside of maps, then your inner collection type needs to be frozen. Your outer one can be non-frozen, but it can also be frozen. You can nest a frozen type within a frozen type, or you can put a frozen type inside of a non-frozen collection. You cannot use non-frozen collections as part of a table's primary key, so at all. But if you use a frozen collection, you can in fact do that because it's stored as a blob value. And the creation syntax for that is just your collection type definition goes inside of triangle brackets with frozen on the left. So just like you would define a set of a type, you define a frozen collection of a type. All right, and we also need to talk a little bit about tombstones. So tombstones in Cassandra are created when data is deleted or expires, but they can also be created by modifying non-frozen collections. So when you completely replace the value, when you overwrite the value of a frozen collection, there's no chance that a tombstone will be generated. But when you modify the value, when you do an update to particular fields inside a collection, you can in fact generate a tombstone. So there's a potential trade-off there depending on how flexible you want your collections to be within Cassandra, whether you need them to fill roles as, say, a primary key or inside of a map or something like that, and whether you're okay with potentially generating tombstones. All right, we're going to move on to the demo in a second. So this is a good time for questions.
Yeah, I just dropped a question in the chat. So like, what would be the use case of like a map versus a list or a set? Sorry, but essentially, like, what scenarios would prefer one collection type over the other? And then would that change pending if you're using a frozen on top of it, I guess?
Okay, so yes, there are different scenarios with really different types. Generally, you just want to play into those attributes. So if you're expecting your data to have duplicates, you can no longer use a set. So like if you want to store two things that are the same text value, say you're storing students at a school, and two kids come in and they have the exact same name. You can no longer have a set of names and differentiate those two students. Therefore, you would use a list or potentially some sort of map, depending on how you set the values for how that works. If you want extra relationships between your data, something like map would be best. So it's a little bit like something you would see in a graph database if you're relating things with a one-to-one relationship or something like that. A map is a decent way to do that depending on how it plays in with the rest of your table structures, essentially. And then a list is sort of like a standard array. So it's sort of the most usable. But if you need to reference things by index, if the order in which things are put in and taken out of that table or of that list is important, then you would necessarily need to use a list versus a set. And then a map, it depends on you having access to the keys at all times. So if you put things into a map and you aren't saving the key anywhere to access later, or you can't generate it again, then you can't really query that data back efficiently. And then
Gotcha.
What was the rest of this question? How does frozen play in? Yes.
Yeah,
Okay.
so like granted, like for the scenarios you kind of provided, like would having a frozen collection type of like change, I guess, the way you think about which kind of collection type you're using?
Yeah, it kind of does. So imagine a set. It has however many items, but once it's created, you can no longer easily append items onto that set. So depending on how you're using it, like if it's just meant to be an immutable store of a collection of data, then at that point, there's really no difference between a frozen set and a frozen list. The order they're returned in is different. But if you can't append to either one, then there's no chance that you're going to be running into duplicates, and there's no chance to change the order in which they're returning to you in the list either. So if you're using frozen collections, basically you just need to make sure that you know how you want to change their values in the future, or if you want to at all.
Got it. Thanks for the explanation.
All right. Any more questions? All right, so moving on. Today, our demo is going to be, we have a small Cassandra cluster up, and basically what we're going to be doing is we're going to create tables with these various collections in them, and we're going to modify them, see how we can modify them, look at the SS tables for them, and then see what modification ability we lose when we're using frozen collections instead. So going to open CQLSH and create a key space. Create a table. So we're going to create a singular table that has all of the types of collections in them. As you can see, we are using professor names as a set, course names as a list, and required books as a map. And the first thing we will do is insert a little bit of data. So starting out with professor names, the set, department name, or no, course names, the list, and required books, the map. And if we just look at it, so what we have here, department name is just text. Professor names, we can see our row 0 that we created has a set of data. So we'll see later that we're unable to add one of these again. It doesn't do anything. And we'll see later that when we insert data, it will show up here back in sorted order again. We can see in row 1 course names, our list. And we can see down here in row 2 that we have our map. Each course here, existentialism, is related to, in this case, it's a string that contains a comma separated list of books. So if you are taking the existentialism class, you need to get being and nothingness and the ethics of ambiguity. All right. So now we are going to exit out. We are going to node tool flush in order to get that data out of the mem table and commit log and into SS tables. And then we're going to use SS table dump. Yep. And looking at the file, let's see, one data. All right. So we use the SS table dump utility to print out the SS table in JSON format. And what we can see is that each row comes with so course names is our list. So we can see that inside the path variable, there is some unique identifier, which basically has to do with an index. And then we can also see that inside the value section, it's just the data that we stored. But if we move on to the set, what we're looking at is our data is being stored in path and value is left blank. And then if we go down and look at the map, we can see that our key is being stored here in the path and our value is being stored in the value here. And based on this, we can also sort of infer that, you know, the map needs unique keys. So if in the set you try and store a duplicate item, you can't have two of the same path value. But if in a map you were to try that with keys, you would get the same result. It would be equally impossible. So if we open up SQL again, except this time we're going to use update to add a single professor name to the set that is professor names. And if we were to once again look, we could see that rather than appending onto the end, it's actually here where it goes in the sorted order of the data. And we can use that to also infer alongside the previous idea that the path value where your values are stored in set and the path value where your keys are stored in sorry, where your keys are stored in the map are the same, we can infer that if you query your whole map, it will keep the keys in sorted order for you. Something interesting to know. We can also use this same sort of syntax to append an item to our list. And when we look at it here, it's at the end. So we've actually appended it onto the end rather than putting it in sorted order or appending to the beginning or anywhere else in that order. So as you append items to a list, they go one more index down. can also update values in a map. So this is more about how you query your maps. So you give it the key and you can edit the value. So just like if you were editing a particular value within a Python dictionary or something like that. But you can also use the same sort of syntax as a set to add key value pairs into your map. So if you look at it one more time. Oh, that's the issue. The ID for the row with the map in it is actually 2. What we've done here is we've taken the empty map for column 0 and we've added a single element to it. So, and then now that we fixed it, the books for existentialism, rather than being in nothingness and ethics of ambiguity, is now fear and trembling. And if we want to exit out once more, flush our data once again, we can go look at the modifications in the new SS files. So we can see, rather than just the single set of SS table files, there is now a second. So if we were to look at the data section of this, we can see that what we have in this file are modifications to old data rather than entirely new copies. So you can see the original set held these 3 values, but here all that's shown is the modifications that we've made to it. Which means that if you call a read, Cassandra will need to look at both of these SS tables in order to properly give you back your data. And we can actually see that if we turn on tracing and then query something. That's not, how about we get this data. Here we go. So you can actually see here that data is being merged from mem tables as well as our 2 SS tables. All right, moving on to frozen collections. Here we have the same table, but all of the collections are frozen now. We have a frozen set, frozen list, and a frozen map. So we could have potentially taken this opportunity because the books in the map are here represented as a single string. Now that it's a frozen collection, now that we're using frozen collections, we could potentially have our second here be a frozen list of text and have our books passed to us that way. But keeping the tables similar, I probably should have turned tracing off before doing that. All right, inserting our data into our frozen table. right. All right, now we have the same starting table. But if we were to now try and add Claude Shannon back to our list of professor names like we did earlier, invalid query, because you cannot do this incremental update on a frozen collection. But if you were to instead update and replace the entire column like this, it would go through and we would be able to see here that our entire column has changed. So this is how you need to interact with frozen columns inside your Cassandra tables. You will, if you need to update them, you need to update the entire thing. So potentially this can be done in a read and then write sort of method if you need to modify them. But if you are willing to take that performance hit for the value of being able to use a frozen collection in the ways that you need to, then you can do that. But if you want incremental updates, then there's sort of a trade-off that you have to think about. We're actually going to flush one last time so we can look and see that the at least SS table dump is able to get you your data in the same format, regardless of, well, no, actually. So you can see what's stored here in the cells inside the value it's a single value. So it still has the same value, but it's stored in one row here, one row here, and one row here, whereas above, I don't know if it's worth scrolling back up to it, but you can see the previous, not that one, this SS table. You can see previously, in order to store that, it was 3 cells or 2 cells, or again, 2 cells. But if you're using a frozen collection, it will store all that data for you in a single cell, which means, you know, all of the drawbacks and advantages of being able to use a frozen collection. So, like I said, you can't base a primary key on something that's multiple cells. So no using non-frozen collections in any sort of primary or clustering columns. But you could potentially use a frozen collection in those places because it's a single value. It's stored as a blob with this value, a single item rather than a collection of items. All right, that is just about all I have for you today. If there are more questions, feel free to unmute and ask them or put them in chat. And if there are any other topics of conversation that people would like to discuss, we'll have time for that afterwards, potentially.
Hey, Obi. Yeah, I dropped a comment from YouTube. The comment was, maybe I missed it, but can you show how the translate to JSON using the JSON select keyword?
Sure. So this is something, it's a feature of CQL.sh. So rather than You can get back your entire data as a single JSON object anytime you want using select JSON. So basically, we've returned each column, each row as a separate JSON object, which means that our map here is now a nested JSON object. But what
Are there any? Oh, sorry.
Yeah, this is different from what we've been using to look at the SS tables, which is the SS table dump utility included in DSE and other Cassandra installations, that will print out your SS tables in JSON format, which is separate from just getting your data in JSON format.
Yeah, I had one question. Is there maybe a soft limit or hard limit, like you were mentioning, in terms of nesting? So, like, say if you have a map of just nested stuff, right? Is there a soft limit or a hard limit on how deep you could go?
Well, you can only nest frozen collections inside of frozen collections. So in the end, they will all be a single object, so there's no limit on depth there. If you nest a frozen object inside a frozen object inside a frozen object, and then your top level is a non-frozen collection, you can no longer nest any further there. But in terms of like data size limits, I don't believe so, because in the end, what's being stored in your, let's say it's a top level non-frozen collection, what's being stored as an element in that is just a single blob object. So you're dealing with the limitations of Cassandra's blob type rather than dealing with the limitations of collections.
Gotcha, thanks.
All right, any more questions?
No more no more questions from YouTube.
All right, if there are not any, then thanks for coming today. If you are on YouTube, remember to like and subscribe, and feel free to come back next time.
Alrighty, thank you, Obi. I think this was super helpful. I think there was also a comment from Rahul saying that thanks for showing this level of detail. It's worth seeing it interactively, and especially for me as well. I had never taken a look at like the path and values you were showing in the actual SS table. So that was really interesting to see. With that, again, thank you for coming to Cassandra Lunch. Same time, same place next week. Also check out Cassandra.Link for all things Cassandra resources, as well as Cassandra.tools. If you are looking at maybe suggesting tools on Cassandra.tools, you can reach out to me, as well as if you're watching this on YouTube right now, live, or if you're watching it later, make sure you like and subscribe, but also turn on the notification bell. So in case you miss a live event, you can be notified when they're starting or when the live YouTube video is processed. So that way you can keep an eye on it that way.